Hello, everyone. Thank you for joining our webinar, Produce Industry Root Cause Investigation. This webinar today will be hosted by Trevor Suslow, Produce Food Safety Expert and Emeritus Extension Research Specialist from UC Davis. I'm Amy Knock, and I'll be moderating the webinar today. Before we begin, I just wanted to share a couple of updates for you on how the webinar will run. The webinar is being recorded and the slides and recording will be available to you within 3 business days. A short Q&A session will follow the presentation to answer any viewer submitted questions. During the webinar, you can submit questions you have using the webinar sidebar menu. Select the questions tab, type in your question, then hit the enter key on your keyboard. Remember, you can submit questions anytime throughout the webinar. And now this concludes my brief introduction. I will now pass the webinar off to you, Trevor. Trevor, you may begin your presentation.
Thank you so much, and it's certainly my pleasure to be with you today to talk about a topic that has gained a lot more attention in recent years for a variety of reasons. I will certainly mention some of those. As it relates to the topic and the title, you can see from this title slide that I always include root cause investigation, assessment, and analysis, which is the more common term, as it relates to fresh produce. And the reason for this distinction is that a lot of times, everyday, activities, everyday business needs, may cause to do some sort of assessment of root cause as an investigation. I always tend to try and help people understand, what often happens in terms of the process and the mechanics by calling it an assessment, because more often than not, you don't really have all of the information, facts to do a complete analysis, or, it only has to go so far. So we'll touch on all of those things. So it's really, I'll just continue calling it root cause analysis for simplicity, but some of the general aspects with a fresh produce slant. And what I won't be doing today is going through a lot of the mechanics and the organizational, operational aspects. There's so many wonderful resources to do that. I will actually mention one that is specific to the produce industry that just came out yesterday, and I'll provide that as a resource at the end. I always will talk a little bit about the components where hazard analysis and risk assessment become involved, as it relates to root cause analysis. Often this can be done, I would argue, in advance, to really continually assess and reevaluate the quality of the hazard analysis and specific risk assessment to anticipate something that might happen or to reverse engineer it, essentially. And the root cause analysis is really questioning whether the hazard analysis and risk assessment were done correctly. And then, it often involves, quite a bit for produce, environmental assessments, both in the field or say pre-harvest, as well as post-harvest, and it may continue across the supply chain. And then I will try and integrate this with a few examples from my own activities and involvement in all of this. So, when we talk about root cause, analysis, investigations, or assessments, I wanted to just make the point, although today is about food safety, and, that is one of the more prominent aspects and applications that is, part of the dialogue today. I've probably done as many, perhaps more, around produce quality or condition, particularly as it relates to, arrival from a shipper to a receiver, and trying to understand forensically what happened along the way. But today I will focus on the foodborne pathogen component, and a lot of this is done in response to an outbreak, and clearly there, say, would be a regulatory and enforcement agency, public health agency involvement in root cause analysis, very formal process. Not that that a lot of the elements aren't the same, but that is sort of a different level and a way that is occurring around outbreaks, but certainly the industry itself, with various partners, try to understand, an individual outbreak or really, a recurring outbreaks and contamination events that might be happening. Again, a root cause analysis might be done and is being done in response to a recall situation to understand, again, how to prevent where did the contamination come from. And then in response to various terms, I'm calling this stock recovery. Some folks would call it market withdrawal, but basically the shipper or the owner still has control over the product, but something has come up. Somebody did a test either internally, externally. There's a reason to be concerned about the safety of that product in commercial markets, and it's removed. But very frequently, there's a value in conducting a root cause analysis in response to pre-harvest testing that has led to a positive detection of a foodborne pathogen or some other element. We're really talking about pathogens, but it could be a physical hazard. It could be a chemical hazard as well, that caused that field to be destroyed, or maybe multiple fields to be destroyed. And particularly, if that is, happening, in a recurring way or a seasonal way, in response to something else that isn't being understood. And that image on the right of your screen is one of the ones that I was involved in early on. And as I will share with you later on, the resolution, the specific root cause isn't always definitive, but you learn a lot along the way, and it helps improve the systems. It helps improve the management. In this case, clearly a large scale cross contamination event that was more post harvest, but it was really the predicating factors were from the field. So this is just part of the steps that are taken. So wanted to just stop and say, why engage in root cause investigations or analysis. Again, I may be preaching to the choir here, but really it's that cost of failure to prevent a repeat or multiple repeats, and that is a pretty consistent occurrence over the decades that I've been involved in this, where there's really not a root cause analysis initiated until there are multiple failures of the same type on the product, or in a particular location or with a particular supplier. But one thing that we've always experienced is that as you go through that process, if it's done systematically, there's really a benefit to system improvements, even if the effort is largely inconclusive or never definitive around this specifically was the root cause. And the ones done for food safety management, almost always have a co-benefit in improving quality management, across the board. So there's a lot of different positives for doing it, and in trying to capture the data and the information that may be related to it. Obviously, there's business protection, whether it's the brand, a specific commodity or an entire category, or as is going on these days, a real concern for compromising the integrity of an entire region, whether it's romaine lettuce in the South Salinas Valley or variety of crops in Florida due to a parasite cyclospora. There's a lot of concern around figuring out root cause and putting in place preventive controls and mitigation practices. Really, I think, quite often there's a reluctance to enter into a root cause analysis because of the, cost that's going to be associated with that process, depending on how far you take it or what's involved. But quite often, I think it's beneficial to take a long-term view of those investments to prevent the things that really aren't related to an outbreak. The likely involvement or being implicated in an outbreak is far less frequent, far less common than in these pre-harvest test outcome crop destructs or a recall due to surveillance testing or customer-based testing, whatever it may be. The other reason is that it certainly has become much more formalized as a regulatory expectation, largely due to the same factors that I've been talking about, and I'm sure most or many of you are familiar with, these sort of recurring, repeated outbreaks within a particular crop category, region, or just in general, as produce has become much better recognized for its contribution to the burden of foodborne illness, in the U.S. and of course across the globe. So, one of the other components that is helpful to keep in mind if you're not already very familiar with this, since I don't know the audience that would be listening to this, is root cause analysis for fresh produce really that different than, say, for manufactured or more processed foods? And I would argue yes. I would argue it's also in general very different than people try and draw examples from things like plane crash or other types of root cause analysis, forensic analysis, because of the high diversity and variability and often the lack of hard data that one can draw on. So it's very highly variable environmental conditions, even say for one producer or one packing operation, even one processing plant, over the course, say, of a year or a season. Highly variable inputs in terms of what's being produced, where they're coming from, how their sort of history of handling. All of these are readily impacted by not just what you're doing, but the surrounding and often uncontrolled activities of adjacent land or nearby land, and the pre-harvest conditions that existed as it led to that contamination event, or whatever the issue was, can't always be replicated or even adequately understood for a more thorough and detailed root cause analysis. Again, not making excuses. It's just this is the landscape one has to work in, and then you have variable to highly variable product traits, even in the same variety grown over the course of different seasons or in different geographic regions will have different physiological, topographical traits. It may have a very different behavior in even a standardized handling. And then of course with fresh produce you have perishable to highly perishable products, and that can have a variety of impacts. But the primary one is that the product of concern is generally not available to do any type of investigative analysis on. It's long gone out of the market, out of consumers' homes, prior to really understanding that there's an issue. Sometimes that's available. So, each site, each operation, there's certainly general commonalities, but they tend to be unique. There's so much diversity, even within a single category or a single region, and how things are done, how they're handled, and it's not always constant. It changes over time. So one of the things that I think is true is that the hazards may be well known. The broad hazards of water, soil amendments, workers, wildlife, domesticated animal presence, all of those things are well known, but their specific risk isn't always known or isn't always characterized. And seasonally, you have either inconstant or inconsistent risks, and you have inconsistent sources of product. In the environment, the climate, and the specific weather will all influence, what might have happened, and you're trying to sort through this. And then you also are dealing with, where there are changes in the product traits due to, maturity, due to ripening, due to, over-ripening. Handling, within storage, can all affect what might have happened that you need to try and sort out. And you have product traits, as I said, and handling variation, and even handling variation within a single type of product type, depending on where it's going, what it's going to be used for, what channels or buyer expectations, maybe have, what kind of consumer packs may be going on, multiple types of things that are going on, all with this this perishable, and changing fresh produce. And of course, as in many businesses and industries, the nature of the facilities, the nature of the operations, are highly variable from, what we would call more legacy facilities to highly, modernized, sophisticated ones, and different environmental factors. So just kind of laying out a lot of the pieces that have to be accounted for. One of the things that often happens with root cause analysis is it doesn't really discredit the hazard analysis or the risk assessment, but what you're really looking for is, did the site-specific risk assessment fail or really change in season to either something that could not have been readily anticipated, or was missed during that actual event, and trying to recreate that. So I've just put this together as a way to say that a lot of times systematic root cause assessments and analysis, sort of reverse engineering up front, can give you a better sense of the risk, and then that can often help during that actual risk cause analysis, when you have to go back and try and lay out the different predicating factors that might have been involved. So the hazard, both prevalence, or proximity. So it's not just like, how much is there, but how close you are to a particular hazard, all become relevant. And, the concentration, say, of the quantitative aspects of the contamination, what would be likely, but a lot of it comes down to, how well it persists in the open environment or within a packing or handling or processing facility, and particularly opportunities for amplification, certainly of the bacterial foodborne pathogens. So all of that is goes into that equation to understand the risk. So one of the important understandings, in sort of how one would go about conducting a more sort of industry-based root cause investigation or analysis, is that the outcomes are generally not definitive. There's not always a clear or singular factor. It's both complicated and complex, and both complicated and complex in the interactions in an open environment and this highly variable process and degree of process controls that exist. And one of the other issues is that the predicating factors may no longer be present because of the time lag, and this is, everything's moving quickly, and so it may not be observable as you're conducting a root cause analysis. And so you have to rely a lot on records, monitoring, interviews, and more often than not these days, and as companies get more sophisticated about that, and they certainly are, they're often incomplete or inadequate. And the monitoring systems that one might have in place for, say, more manufactured or more conventional processed foods are not sufficiently frequent or sufficiently sensitive to capture things that would be helpful for the root cause analysis. And as so much of this depends on interviews and people's awareness of what might be going on at the time that's not recorded, you often encounter incomplete or certainly conflicting recall. Not necessarily intentionally, just it's often hard and it's often subtle, and if you're not focused or trained on it, you're going to miss things that really would have been very important. So what this often leads to then is settling on very simplistic symptoms rather than the actual cause. And sometimes that may be all you have, and you react to the symptoms that are related to the problem. You try something, and then you haven't fixed it. You go back and you dig deeper. So I pulled this out from the recent past, but the past, just to illustrate, when you put together, and there's different ways to sort of visualize the complexity, the interactions, and how different aspects of what's going on, particularly in the open environment, can affect one another. I'm not going to go through the whole schematic, but you can see that there's sort of an animal feeding operation on one side, and you have the food crop, leafy greens on the other, and you have inputs that can be, impacted in between, and you have vectors, and when you're trying to figure out both how contamination arrived, as it might explain an outbreak, but also where and why a specific pathogen in terms of source tracking, where is this recurring pathogen coming from? Just a variety of things to keep in front of you, and not always have complete data or information, or even the ability to really replicate what might have happened at the time. So it's quite a bit of guesswork. So really then, where to start? Again, as I said, I won't go through, what often is covered in root cause analysis talks such as this, the mechanics, the operational, assembly of teams, and, incident command, and all of that, highly structured. There's lots of places to be exposed to that if you're interested. But it really comes down to defining the problem, making sort of an informed guess to identify an underlying cause, which really leads to your hypothesis generation, or developing at least a starting point, catalyst hypothesis. And as you start to define the problem, you also want to start to define the goals. Are you really sure what is the nature of the problem we want to get at? Why did it happen? Should it have been preventable? Did the hazard analysis and risk assessment fail? Did it need to be revised with either new knowledge or better training, whatever that may be? And what can be done to prevent it? What kind of preventive controls are needed? And especially, more often than not, what types of verification tools or monitoring tools and practices are really needed? So it's all about developing a hypothesis, or multiple ones, which is more likely going to happen, to analyze, test it, evaluate it with all the information that might be available, and then, see, whether it fits, reassess it, and refine. So I've broken it out this way because that's just how I tend to approach this, the sort of incident definition or definition of the problem. They're really all related, but I often break it out into sort of the forensic component and the records and documents review component. And obviously they have to go along together, and what you want them to do is really align as you pull together available facts and data with the other things. And often the records and documents might trigger a level of testing, and certainly trigger a level of a variety of interviews, or even going to external experts to understand some aspect of biology, ecology, or whatever it may be. And hopefully those all converge and then bring you to a better understanding of root cause, whether it's a WAG, often comes out to a wild ass guess, and then you go back and see whether you were right, and sometimes that might be the next year. A best guess, or really actually a confirmed, clearly this was the root cause. So, just breaking it out a little bit, I won't read through all of these again. This is fairly common approaches and often components of everyday business, maybe just not formalized in an organized root cause assessment or analysis. So, external data might be coming to you, combining that with internal data or data trends, and trying to align all of those, that information around specific locations. And again, I'm leaning on produce here, so it might be a production location or a processing location, or across many that might be possible. And then the timelines of when something happened. This is especially relevant, in root cause analysis related to outbreaks, because of just the nature of the industry today. Won't go in through all of the details, but it really is the details make all the differences. And then really drilling down to specific activities, practices, and the different aspects of the product itself, and then any types of secondary storage or secondary distribution, to try and understand the distribution of product that caused an issue. And again, as I said, they could really trigger different types of testing. It may be testing on product, if you happen to have retained, or even if it was retained in a consumer, that would be more a regulatory activity. But investigative product testing, it may implicate a product that's still in the field, still in a cooler or someplace else. And then it may be, may engage in environmental testing, looking for evidence of the specific pathogen in a specific implicated environment, either pre or post harvest. And equipment, evaluating process controls. And I also include testing in the training aspect. What is the knowledge, the competency, and the performance that might have led to the actual event happening rather than being prevented in advance. So I'm going to switch to a couple of case examples, hopefully to illustrate this. This is one approach in practical root cause assessment. You go through problem identification, try and identify the predicate factors. You take a primary determination and ask, does this fit? Does this not fit? And then hopefully you get to a resolution and then verify and evolve your system. I know that maybe without knowing who's on the line, I've used this one before, but I think it's a good illustration of this type of approach to constructing root cause analysis. So here, pre-harvest Shiga toxin producing E. coli was detected, in multiple times in the same field in consecutive plantings on tender greens, baby greens. The knowledge as it related to trying to initially organize what might be going on. It was deep well water, well characterized, so would not appear to be the source. No specific soil amendments were added, so compost or manures were not likely a factor here. There was no flood event. So these are just the normal things in terms of hazards that one goes through every time there's something going on with a produce item. So some of the predicating factors, based on location, it was near a riparian zone, and the preceding crop was carrots. Initial assessment of the environment, Shiga toxin producing E. coli were detected in the runoff water or tailwater ditches. So then you go back and look a little bit deeper. So there was, within the environmental, assessment, there was evidence that there were certainly, animals and animal feeding on remaining root carrots. And, what prompted this is that, the field was, delayed in disking due to a variety of operational limitations. And then, it did start raining the preceding season, and that made it really, not possible to get into that particular piece of ground with equipment to do any groundwork. And therefore, there were a number of carrot roots still in the ground on the surface, because if you then go look over here, that it happened to be organic carrots. It happened to have encountered some foliar disease. Therefore, the tops were not strong enough and not abundant enough for mechanized harvest. And so there was a lot of carryover carrot roots, and that became this attractant for both deer and feral swine the preceding winter. So, in terms of root cause resolution, really the need was to, ideally improve site selection and really, develop an understanding of the importance of timely groundwork. Or once they got into a problem that could have been an attractant potential, knowing that they're near an area where wildlife intrusion was likely, there would be a need to remediate this STEC survival. So, the process then led to confirming that, with multiple tests and multiple soil groundwork, that at least the detectable level of the Shiga toxin producing E. coli was reduced below sort of back to baseline levels. And then really there was that training component of training, the schedulers, the field foreman, and even the sales department, that the importance of site selection and what might happen, if something went wrong. There's another common tool that's used that I think is actually not that easy for fresh produce, mostly because it's hard to answer the why part, but it's called the 5 whys. Many of you may be familiar with it. So just a quick run through of a cantaloupe shipment that was rejected for cause due to salmonella detection. So, why was it rejected? Salmonella was detected on late season cantaloupe. Why was that? Well, it was unusual but plausible risk of harvest operation cross-contamination. Why was that more likely than what would be typical? Overripe and damaged fruit were in the furrows, which is not uncommon. That's the typical part. But they were in contact with probable salmonella contaminated irrigation source water, which is not typical and would not be expected. So why was that? That cross-contamination, of fruit, because they were the fruit close to or actually laying in the furrows that carried that water were included in the harvested lot. And normally they're irrigated very carefully to prevent that water crossing the bed, and the soil actually does a pretty good job of filtering and preventing transfer of what's in the furrow in terms of bacteria across to those areas. So why did that happen? Well, as one might expect, market prices, and demand resulted in extended duration of harvest, and these cantaloupe fields are multiple harvested as a normal process, and there was a decision to kind of bypass the normal quality SOPs, which then elevated the risk. So again, just sort of an example, a real example, and a lot of it was related to adjacent fields at the time, that they flood the fields, alfalfa fields, and that runoff water was returned to the irrigation canals, and that water then, that was coming up from upstream to downstream was used for irrigation before irrigation cut off. But the salmonella has an amazing capability to survive on the soil. So all of those things made it difficult. One of the more common ones one hears about a lot is using a fishbone diagram. Certainly I've done that. One of the challenges, I think, of applying this to produce is that if you do it sort of the superficial way, everything always looks the same. So just some common examples. You define the problem. As I said, you develop some initial hypothesis, and then you develop basically the backbone, and then lay out all the different activities, unit operations, and components, and then fill in the details. The goal here is that step 4 is to really, on a very location specific and timing specific with facts and data, rule in or rule out each possible element, and can continually refine and revise this and challenge sort of the goodness of fit of any element to root cause. So this is a busy example, but I thought this is just sort of typically, what one goes through, this, related to, recent whole bulb dry onion outbreak with salmonella. And this basically, I did this if you have enough knowledge and you're aware of the diversity, of production, diversity of management, you can construct these fishbone diagrams with a lot of elements that are not specific to what happened, not specific to the operation because you haven't started yet, but then you start to say which ones apply, which ones pull out, and there's the production side, there's the sort of post-harvest packing and shipping side, and you start to look at which one of these might have applied. This is a little bit different, bigger view, so maybe some of the things that could be relevant that you would ask in the even before you get started, knowing that there's a lot of variability, say in the nature of the harvest practices, what is going to be relevant, drill down to that quickly, look at what was going on in the packing operations, even pre-season, before they got started, what kind of elements might have been different that particular year. So again, without going through all of this, just the point is details make the difference. Knowing specifically what applied, not just what is generally relevant, is how you walk through that process. This is a bit of a different example. I have to be careful showing some of these images, but I thought it was useful to really point out one thing where the composition of your root cause analysis team is really, really important, and continually drilling down to capture what might be known. So on the far left, as always happens, water is one of the questions, one of the things that gets looked at pretty immediately. And when they have a problem with sort of recurring pathogen detection, testing the water, doing more to test the water, never stood out from the canal, never stood out as really being the issue. But in the middle, knowing that they were in, relative proximity to dairy, animal feeding operation, and because of changes in the environmental management of the water, that often the dairy wastewater lagoon circulated around. It's always been used to irrigate silage crops to use for feed, but also just sort of transferred around in different ditches or small canals and then returned to the dairy. And what wasn't apparent for some time, because one team member knew this but wasn't included in the process, but then on the site evaluation, the far right, so what's going on here? It's basically how this starts. It's like, oh well, periodically they actually, over the years before this field was converted to fresh produce production, having been used for silage production for a long time or other non-food crops, they pumped the dairy waste lagoon water, blended it with canal water, and put it out in the field. So, this was just one of those elements that until that was discovered, some of those possible root cause factors, were missed. So I emphasize water a lot because in many of these produce-related root cause analysis, water involvement, either as a clear root cause or certainly a symptom of environmental contamination, pressure, are always there. And this is from an outbreak way back in 2006. But I think it really illustrates very well, just the kinds of things that you need to look for, the kinds of understandings. You have a very complex, water conveyance, water distribution system with many components, with the potential for cross connections between dairy and produce production, which was sort of a new venture, in this particular case. But the real root cause seemed to be this gate valve was inappropriate for for excluding the solids, and for dealing with the solids that might be in the wastewater lagoon water that's being transferred around to different fields in proximity to the production field, and was fine when it was first put in, but it was the wrong type of gate valve, and then wear over time allowed it to stay perhaps open, and when water was being sent to the field, actually drew in water from the dairy side. So again, not saying that it was ever absolute, but that was certainly the conclusion by the public health agencies, and just again illustrates the complexity of what one might be looking for. And then here's another one. I wanted to make a point that, in outbreak root cause analysis for produce, contamination may not really be the practical root cause of what happened. Obviously, zero contamination from foodborne pathogens may be the goal, but not necessarily realistic. And it's really the cofactors that were key in terms of the consequence and the severity. So here, what I've done with the red line, so it's a little bit easier to see, is that one of the components was failure to maintain produce handling equipment to prevent injury. So these sort of conveyor lift paddles that bring in product, into the packing environment were, multiple ones were broken, fractured, and caused puncture points, and perhaps allowed for bacterial amplification, which was really the root cause, more so than contamination. Just sort of kind of moving to more different types of environments, root cause analysis really led to a seek and destroy in a greenhouse herb operation, which led to discovery of established listeria within the recirculated water system filters, which weren't treated at the time. And when the facility is new, there were no problems, but with time, these things can build up. So that led to establishing environmental monitoring program, a level of antimicrobial treatment consistent with product quality and the management scheme that they had, And then, periodic deep cleaning, and quarterly shock treatment just as preventive controls. Again, one of these sort of complicated schematics, again, don't have time to go through all of the different nuances here, but the point here is just, again, sort of repeat Listeria positives within a relatively newly established environmental monitoring program. And you can see where all of these circles are sort of, buildup of both Listeria species and Listeria monocytogenes, trying to understand specifically where the ones that appear to be resident or continually reintroduced to this packing operation were coming from. And, I'll just mention that what really came down to, by characterizing the subtypes that were there, that a lot of this was actually due to seasonal runoff. This is when they had the most problem due to rain. And the drains all drained into different areas that were right in front of entrances where a lot of equipment was coming in and continually reintroducing it, into the facility. So it was really by doing, not just the environmental monitoring, but really drilling down to, the ones that seem to be continually reintroducing the same Listeria back into the facility, was really the effort. So as a wrap up here, this at the end, I really want to make the point that it's really important to have a plan as there's more and more pressure to do root cause analysis, to triage, each incident, and every root cause analysis effort is not always profitable. It can get very expensive. You really want to evaluate it for, as you go through it, with at least always, some effort, but to keep going, to keep pushing for definitive root cause. What is the likely knowledge gain? I always assess how reliable is the information that's going to be available. What's been recorded. Temperature monitoring would be an example. Was there temperature recorders? Is that available? Or did they disappear? How much effort generally as it relates to testing, environmental testing, field testing, product testing is really worth the investment, or testing, for wildlife as the root cause. So, sort of have a plan or a certain threshold to pull the plug, and sometimes, a good enough decision is going to have to be good enough. And then monitoring, testing of whatever you decided should really follow. So sometimes you kind of end up with some uncertainty or a good deal of uncertainty. You've undoubtedly learned some things along the way. And then go back and reevaluate the entire process. And it cannot, to me, underestimate the value of really going through and continually, sort of questioning and reassessing the hazard analysis and risk assessment as you learn more about the vulnerabilities that you have. So this is what I mentioned up front. This is just out. It's available through the United Fresh, through Western Growers. It's a how-to guide that was produced by a group. It's one of the last things that I participated in as within my role at the Produce Marketing Association. And I think it has a lot of that structural components, but also some very detailed case examples that kind of lay out, this is what one might go through, and these are the steps that might be necessary, and that link is available. And this I decided to put in, it's just informational, it's not an endorsement, but there are a number of applications that will help you do this. I'm sharing this one because it was free, starting to play with it, but it seems to be a nice way, for folks to get organized, to help to do this yourself, with your team, and incorporate a lot of things just in a pretty nicely designed Excel freeware. So with that, thank you very much for your attention. And if there's a time, I'd be happy to answer any questions that might come up.
Thanks so much for your presentation, Trevor. I am just going to go ahead and launch the poll right here now. Again, if anyone would like any follow-up after the webinar, please submit the information right here. And we have had some questions come in, so I'll go ahead and start those. The first one for you, Trevor, is we do root cause after an event, and we are always sure to complete the RCA and file it away. That being said, we haven't been able to really pinpoint a true root cause in most cases, just beliefs on what might have happened. What do we do in those situations, since it feels like we are just filing away a document, but not really doing anything to prevent it from happening in the future?
Sure, that's both a great question and a very common, outcome of these efforts. And I think, the best answer I can give you is that if you haven't already done it, it can often be very informative or helpful to have somebody else take a look at the situation, take a look at what you've done, after the fact that you filed it away with a different set of eyes, and ask some questions. And often, even if they don't know your process, don't know your system necessarily, somebody that sort of has some expertise in what to look for and what's missing might be able to probe a little bit and help you self-identify some things that might be missed, or there might be, something, I'll just say from personal experience, that you did a great job, but you weren't aware that this aspect of either the crop, the biology, the nature of, soil, or, something else was missing. You had that missing component that didn't let you get a little bit closer. Sometimes you just can't figure it out.
Okay, great. Thank you for that. And then the other question here is what types of testing should you include in your root cause analysis? And should you try different tests since pathogens aren't always easy to find?
Sure. Again, these are all I think, part of the decision process as you work through, the nature of the problem, what your best guess at hypothesis, related to root cause is, or how that changes as you go forward. Sometimes there's opportunities to test specifically for the pathogen, or you might say, well, it's too late for that, but we want to look for any evidence of, fecal indicators, might be. But you really have to, as I said, carefully evaluate the likelihood that that's going to end up being informative, rather than just, throw dollars at the problem with the low probability that it's going to come true. So a little hard to answer other than on a case-by-case basis, but we generally say you can, there are indicators that are helpful, or index organisms that have a similar survival, or might be, sort of also present if the pathogen had been present. Sometimes, it's not so much about testing, microbiological testing, but it might be, evaluations of equipment, and surfaces and cross connections and things like that.
Okay, great. And another one that came in, can you tell us the acceptable limit of Salmonella, Listeria, mold, and yeasts on pre-harvest testing of produce?
Yeah, I like the way that question was phrased. So that, there certainly are, product specifications that generally are customer specific. There are very few sort of generalized ones. There are a few schemes, not so much here in the U.S., but in Europe and other places, where certainly for yeast and molds, there have been levels for things like generic E. coli, but in general, the standard for human pathogens is 0. So we always say, what's the accepted limit is different than the acceptable limit, and we're actually trying to to make that argument for at least having a dialogue around a quantitative level that depending on the pathogen, the product, and how it's used, so that we stop destroying a lot of product that probably has very, very low probability of public health consequence.
Great, thank you so much for that. And I've been monitoring here. It looks like there just have been some other administrative questions, so I'll just address them here before we wrap it up. But just a reminder, we will be sharing the presentation as well as the recording by email. So you'll get that within 3 business days. We'll be sending that out, the recording, the slides. And if you want someone to follow up with you, if you have noted yes, we will certainly reach out. So again, I would like to thank you, Trevor, for your expertise and your presentation today. Yep, and thanks everyone again for attending. Have a great rest of your day.
Thank you, bye.
Thank you.